Okay, this video is for section 8.3 in your book for geometric sequences and series. So the first important thing for us to talk about is the explicit formula to find the nth term of a geometric sequence. That's this formula right here, a sub n equals a sub 1 times r to the n minus 1 power. Just like in the arithmetic sequence, a sub n is the nth term. A sub 1 is your first term. N is the number of terms that you have, but R is a little bit different. R is called the common ratio between your consecutive terms. So in order for us to figure out what R is, we have to take one term and divide it by its previous term to find out what the ratio is, that common ratio between the consecutive terms. Okay, so for these two examples here, we're going to find the formula for the 13th, or find the formula, and we're going to find the 13th term. So we have 4, 16, and 64. Okay, in order for us to find the formula, we need to know our first term, which we do, that's 4, and we need to know our common ratio. Okay. So to figure out what our common ratio is, we're going to take 16 and divide it by 4. So I took a term and divided it by its previous term, and I get 4. To double check, you need to make sure that the next given consecutive term, 64, divided by its previous term, 16, does that make 4? And the answer is yes. So our common ratio is also going to be 4. Okay? So our formula for our nth term is a sub 1 times r to the n minus 1 power. And we're asked to find the 13th term, so we're going to find a sub 13, our 13th term. We're going to take our initial term, 4, and multiply it with our common ratio, 4, raised to the 13 minus 1 power. So when we figure out what a sub 13 is, six, 7, 1, 0, 8, 8, 6, 4. So 67,108,864. Okay, our second example is done in exactly the same way. 8, 27, and 9. Our first term is 81. We don't know our common ratio yet, so let's figure that out. We have to find R. We're going to take 27 and divide it by its previous term, 81. That simplifies to 1/3, or reduces down to be 1/3. Okay, is 9 over 27 equivalent to 1/3? And the answer is yes. So our common ratio is 1/3. So let's find our nth term. In this case, it's going to be our 13th term. So our 13th term is going to be equal to 81 times 1/3 to the 13 minus 1 power. Okay. As a fraction, the answer is 1 over 6,561. Okay. Now we're going to find the first term if we know our 8th term and we know our common ratio is 4. Okay, so our geometric sequence formula, a sub n equals a sub 1 times r to the n minus 1 power. Okay, so we're trying to find our first term, which is a sub 1. Okay, we know a sub n, that's our 8th term. Okay, a sub 1 is staying the same because we're trying to figure out what our first term is. Our ratio is 4, and we're raising this to the 8 minus 1 power. Now all we need to do is to simplify this. This would be a sub 1 times 4 to the 7th power. Okay, and we're going to divide by 4 to the 7th power to isolate our first term. And when you work that out, you're going to get 1/2. Okay, so now we can talk about finding the sum of the sequence So our series is the sum of the sequence. This formula here is a summation that you can use to actually put into your calculator or to use and find it by hand. Okay, this is also another formula for you to use by hand. So this would be primarily for your calculator and primarily for by hand. Okay, both of these formulas need to be memorized, not only for your quiz but for your test. Okay, so let's find the sum of these two examples. We have our first term is 8, our common ratio is -2, and we have 7 terms in the sequence. So let's use the summation notation for this example, and we'll use the other notation for the second example. Okay, so we're trying to find the sum of the first 7 terms. Okay, first term to our 7th term. Okay, and we're going to multiply that. Our equation is 8, our initial term, times our ratio to the n minus 1 power. Okay, so let's put this into the calculator. Okay, so from x equals 1 to 7, we'll have 8 times -2 to the x minus 1 power. Okay, so our sum of the first 7 terms is going to be 344. Okay, now let's use the second equation for finding the sum of the sequence, or find the series. Okay, in this equation, so if s sub 7 equals 5 times 1 minus -1/2 to the 7th power over 1 minus -1/2. Okay, and we can put this into the calculator. Okay, so that's 3.359, blah, blah, blah. So I just want to make that into a fraction. A little bit more exact. 215 over 64. Okay, so that's the sum of the first 7 terms. Okay, so now we're going to be talking about infinite geometric series. Okay, so that's when we're continuously adding up all of the terms within the sequence. So we have 2 cases here. We have the sum of the geometric series. We have 2 cases where it diverges and where it converges. It diverges if your common ratio's absolute value is less than or equal to 1, and it converges if that absolute value is less than 1. The reason being is our arithmetic sequences are really linear functions, okay, and our geometric series are exponential functions. So we'll have the case where it continuously grows at a rapid rate, or where it decreases at that rapid rate. Okay, so when it diverges is when it's continuously going up, and it's going to go up forever. It's converging down to a sum because it's going to get smaller and smaller and smaller, little bits and bits and bits and bits. Okay? So if it converges, we're going to use this equation right here, or you could use the summation notation. Doesn't matter whichever one you prefer. Okay, so let's work through 2 examples that use this. Okay, so determining if the infinite series converges or diverges. If it converges, we're going to decide what it converges to. Okay, so the first thing that we need to do is we need to determine our common ratio. So we'll take 2 to 8, and that is 1/4. Okay, now the absolute value of 1/4 equals 1/4. Okay, So this is the case where it's going to converge because the absolute value of our common ratio is less than 1. Okay, so since it converges, we're going to decide what it converges to. I'm going to use this formula, a sub 1 equals 1 over our common ratio, which will be 8 over 1 minus 1/4, and that works out to be 32 over 3. Okay, so our sum is going to converge to that. Our second example, we have the terms 2, 4, 8, and we're continuously adding on. So our step 1, we've got to find our common ratio. We're going to take 4 and divide it by 2, and that's 2. Now the absolute value of 2 is equal to 2. And this is the case where your series is going to diverge because the absolute value of r is greater than or equal to 1. 2 is greater than 1. Okay, so that's all that we have for these notes here. You can look at Fusion or at your calendar for Chapter 8 to see what the assignment is for Section 8.3. The homework's on page 582.